You know that sound, that satisfying roar when your car's engine kicks into life? It's just so familiar, right? But have you ever stopped to think about what's really happening? You turn a key, and suddenly this tiny, hidden device unleashes enough force to get thousands of pounds of metal moving. So, how on earth does it do that? Well, today we're going to pull back the curtain on the invisible force that makes it all happen. All right, so this little guy right here is the hero of our story. This is the starter motor. And here's what's so wild. For the absolutely massive job it has to do, cranking an entire engine from a complete standstill, it's surprisingly small. I mean, it's really compact and pretty lightweight. So that's the big question, isn't it? How does this little device generate enough raw power to fight against all the engine's compression and friction? I mean, we are talking about a massive amount of torque here, all coming from something you could basically hold in your hands. The answer? Well, it lies in this really brilliant combination of electricity and magnetism. Okay, let's crack it open and take a look inside. What you're seeing here in this cutaway is it's like a symphony of engineering. You've got electromagnetic coils, you've got precision gears, a drive mechanism, and it all has to work in perfect sequence. It is, without a doubt, a true powerhouse in a very small package. So the secret sauce here is a fundamental principle of physics, electromagnetic force. It sounds complicated, but the idea is actually pretty straightforward. When you run an electric current through a wire that's sitting inside a magnetic field, boom! A powerful physical force is generated, and it literally pushes that wire. This simple yet incredibly powerful concept is the entire reason the motor spins. Okay, so how does a simple push turn into powerful rotation? Let's break it down. It's basically a four-step dance. Step 1, electricity flows from your car battery and lights up these coils. Step 2, this creates a really strong magnetic field. Step 3, that magnetic field then pushes on the motor's core, which is called the armature. And finally, through some really clever engineering, this continuous push is transformed into a powerful spinning force. All right, so we get it. The motor needs a whole lot of electricity. But here's the thing. It's not just about how much power we throw at it. It's about the kind of power. So what type of electricity is the secret ingredient for creating such a smooth yet immense turning force? Let's dig in. And this brings us to a really key concept: single-phase versus three-phase power. Now, the power you get from a regular wall outlet in your house, that's single-phase. It comes in one single wave of electricity. It's totally fine for, say, a lamp or your toaster, but it's pretty choppy and inefficient for a big motor. But three-phase power, now that's a different beast. It delivers three perfectly synchronized waves of electricity all at once. The result is a constant, smooth, and way more powerful flow of energy. It's exactly what a heavy-duty motor needs. Here's a great way to think about it. Imagine trying to push a really heavy wheel all by yourself. Your push is going to be jerky, right? Kind of inefficient. Now picture three people pushing that same wheel but in a perfect smooth rhythm, one after another. That wheel is going to spin smoothly and with a ton more power. Well, that's pretty much the difference between single-phase and three-phase power. And this leads us to what is, honestly, the magic trick of three-phase power. It's called the rotating magnetic field, or RMF for short. By feeding those three synchronized electrical waves into the motor's coils, we create something amazing: a magnetic field that actually rotates in space, all by itself. There are no moving parts making it happen. It's a purely electrical phenomenon, and it's kind of mind-blowing. And get this is the really cool part. The math actually shows that this combined rotating field isn't just constant. It's actually stronger than the peak strength of any one of those individual waves. To be exact, it's 1.5 times as powerful. So you get smooth, constant, and amplified power all at once. It's a total force multiplier. So let's watch how this actually creates rotation. Okay, at the very first instant, at time 0, the magnetic fields from all three phases combine. When their forces all add up, the total magnetic force points straight up. Now wait just a fraction of a second. As those three electrical waves continue their cycle, their individual strengths change a little bit. And what's the result? The direction of that combined magnetic force has now rotated clockwise. And this just keeps on happening, over and over, seamlessly. It creates a magnetic field that spins in a perfect circle. This invisible rotating force then basically grabs onto the motor's central shaft, that's the rotor, and just pulls it along for the ride. That is the source of the incredibly powerful and smooth torque that gets your engine started. Okay, so we have this amazing three-phase system, and it's creating this invisible rotating force. That's the theory. But what about the practice? How do we actually wire all of this stuff together? How do you connect the coils inside the motor to make this magic happen? Well, it turns out there are two main recipes for wiring it up. You've got the star connection, which looks kind of like the letter Y, and the delta connection, which forms a closed loop like a triangle. And they each have really different characteristics. The big one is that star connections have a central neutral point, but delta connections don't. And that single difference has huge implications for how they're used. It can determine if a system is better for, say, sending power over a long distance, or for running a super high-powered motor right here, right now. So that neutral point in a star connection, it's a massive advantage when it comes to versatility. It gives you a 0-volt reference point. What that means in plain English is that the system can run a powerful 3-phase motor, but it can also easily tap into that to supply lower single-phase voltage for other stuff, like your car's radio or the headlights. It's kind of like having both a high-power and a low-power option built right into the same system. In this brings our whole story full circle, right back to your car. Because what you have under the hood is a perfect partnership. The alternator, that thing on the left, is basically a mini 3-phase power plant. When your engine's running, it's generating this beautiful, high-quality power. And then, the starter motor on the right is designed specifically to use that exact type of power for the single toughest job in the car, cranking the engine. One creates the perfect power, and the other puts it to work. It's beautiful. And you know what? This isn't just about cars. Not at all. The exact same principles, 3-phase power, rotating magnetic fields, they're at work all around us, but on a massive scale. We're talking from the giant generators at a power station that light up our cities, all the way down to the tiny little alternator under your car's hood. This invisible force is everywhere, constantly at work. So we've just pulled back the curtain on one of these amazing hidden systems that power our world. And now that you've seen the invisible force that actually starts your car every single day, it kind of makes you wonder, doesn't it? What other hidden systems are out there, quietly and invisibly making our daily lives possible?